All right, guys. Module 4, Lesson 3. Shoot, on the wrong one, so let's go ahead and go to the correct one. 4-3. We're doing 1 through 20, I believe. All right. How many points of intersection are on the graph? So number 1 starts off nice and easy. Let's go ahead and get 1 and 2. I'm sure our lives can't stay this easy, but you know, we do what we can. So how many points of intersection? There is 1 point of intersection. That's it, right there. And that's at 1, -3. 1 point. 1 point at 1, -3. How many points of intersection are there on this graph? Y equals x squared plus 3x minus 2, y minus x equals 4. Well, we need to complete the square. So we're going to have y equals x squared plus 3x. Half of 3 is 3 over 2. So 3 over 2 squared minus 2 minus 3 over 2 squared, because I need to balance it out. So I have y equals x plus 3 over 2 squared minus 2 minus 9/4. So let's get a common denominator of 4 over 4. So we're going to have -8/4 right there. Oop. -8/4 minus 9/4. So that's going to be -17/4. Which, since we're graphing, guys, let's go ahead and convert that. So that's -17 over 4, which is -4.25. So y equals, once again, only because I'm graphing, I'm going to change that to that. 3/2 is 1.5 minus 4.25. So our vertex, mind you, is at -1.5, comma, -4.25, and it's a parabola facing up. So that's kind of like our question 2 on our workbook. Here we're going to add x to both sides. We're talking about the line now, so I'm way up top. Okay. So y equals x plus 4. So that one's a 1 over 1 slope. So since this is just really easily, it's not asking exactly where does it cross. It's just asking how many points are there on the graph. So the fact that our parabola has a vertex at -1.5, so -4.25, I can just kind of put it right there. And I know my parabola, is going to look like a parabola. My line, way up here, goes through 4, maybe right there, and has a slope of 1 over 1. So it's just going to be a diagonal line. So it's pretty obvious that this is going to cross twice, and that's the only thing. So how many points of intersection? There are 2 points of intersection. Be on the lookout when the problem's easier. I did need to figure out exactly where that vertex was so I could get a semi-accurate graph, but nothing crazy. All right, 3-4. Solve the given linear quadratic system graphically. If necessary, round to the nearest integer. So we've got lots of graphs. Let me talk about those. So we've got 1, 2, 3, 4, 5, 6 of them. We have 6 of these graphs, guys. You don't have to do every single one super hard, though. The first, actually, you know what? This is not bad at all. This is not bad at all. If you guys have the ability to print these so you can get your own graphs, it makes your life even easier. That's just a lot of printing on our end. I already print out your guys' notes, so I didn't want to lose anything here. So we have a parabola. This is a vertical parabola that's facing down, right? It's reflected vertically. And the vertex is at 2, 4. Okay, vertex is at 2, 4. And then it goes, we can say it goes over 1, down 1. And then it's going to go over 2, down 4. And it's going to go over 3, down 9. 4, 6, 8, 9. So there's my parabola. the best of my ability. Y equals -5. Now that's just going to be a horizontal line through -5. Where does it cross? It crossed, hey, at those two dots right there. That is -1, -5 is one crossing. And the other crossing is 5, -5. Right? So those are our two solutions. I'll make the dots really big. They're right there, right there. Okay. Next one. Okay, so we're going to add 3 just so it looks like my vertex form. I don't know why we have a different form for a parabola, honestly. How many forms do we need? All right, it's kind of like slope-intercept form. It's really the only form we need. The point-slope form can work sometimes. None of them never work. Okay, so we have an upward-facing parabola, and its vertex is at 1, 3. Okay, so 1, 3. I'm going to put my dot. There's my vertex. It goes over 1, up 1, over 2, up 4. That's probably all I'm going to be able to fit on this graph. There's my parabola. Oh, I like that parabola. Here I need slope-intercept form, so I know what it looks like easily. So I get y equals -2x plus 5, so it's going to go through 5, and it's going to go down to over 1. So it's going to look like that, to the best of my knowledge. So it crosses twice. What are those crossings? Looks like it crosses through the vertex, so one of the solutions is 1, 3. And then it crosses at this dot up here, which is -1, 7. 5, 6, 5, 6, 7, 8. No, we're doing these two. They're still being really nice to us. We have to be careful here. This is going to be a horizontal. This is going to be right opening. It's going to be a right opening parabola. And it's been shifted 5 to the left. Be careful. Because of the fact it's horizontal, that's not an up and down, that's a left and right. So it's right opening and it's shifted 5 to the left. So there's our vertex, and then we're going to go over 1, up 1, over 2, up 4, over 3, up 9, and there's our sideways parabola. And here we're going to have to add x to both sides. A couple more steps on this. So now I've got 2y equals x plus 12. Let's get y by itself dividing by 2. Don't forget there's a 1 in front of that x. So y equals 1/2 x plus 6, because that 2 divides into both of our objects up there. So that means it goes through 6, and then it's got a slope of up 1 to the right 2. Which also means it has a slope of down 1 to the left 2. And we can see that this particular linear quadratic model has no solutions because it has no points of intersection. Because it has no points. Here we have a sideways parabola. Moving on to number 6. All right, so I have x equals. So now my vertex is at 4, -1. Don't forget it's swapped because I'm at the horizontal parabola. Here I get to subtract 3x, and I get -y equals -3x plus 17, and I'll multiply both sides by -1 to get rid of that negative. On that, distribute. Y equals positive 3x minus 17. Why did they ask us to solve this graphically? 17 is not on here. Oh well, we'll figure it out. Okay, so coming back to our parabola, it's right facing, and its vertex is at 4, -1. And so then we go out 1, right 1, out 2, 4. Oh. There's our parabola. And then y equals 3x minus 17. So that means it starts way down here. So somewhere down here is -17. It starts way down there. Then it goes up 3, which is -14 over 1. up 3, which is negative 11, over another 1, so now I'm over 2. Then I go up 3, which is negative 8, and I'll be at over 3, so that's the first place. Then I keep going up 3 over 1, up 3 over 1. Holy smokes, it does cross. Up 3 over 1. That one's a bit of a miss, possibly. But still, it just said to round to the nearest integer to talk about where it crosses. So we're just going to round that. I can see this one's a solid dot right here, so that's at 5, negative 2. 5, negative 2 is one solution. And the other one, we're going to call this dot right up here, we're going to call that 7, 1. Might not be. Makes me want to bring out Desmos to double check it. But time-wise, I'm not going to bring out Desmos to double check. And guys, don't forget, if you want to earn some points, by all means, I'm only human. I make these on the fly. I've never seen the answer keys to these. I'm just going. If I make an error, you call me on it. I'll throw some points your way, hero points. We'll have a laugh. Okay, wow, this one, 7's a complicated one. This is one where, you know, it's almost like, this is, I mean, we can do it, and I know you guys can do it, but how much time do we want to spend on it? Now, the line is really easy. The line is x equals y. So x equals y is simply the diagonal line cutting through our entire quadrant. There we go. All right, now the other one, I'm going to add 12x to the other side. Okay, so coming down here, I'm going to have y minus 4 squared plus x squared plus 12x equals negative 20. We need to complete the square, so we're going to add 6 squared. Add 6 squared. So now I've got y minus 4 squared. This is a perfect square. We've been doing that. We get x plus 6 squared equals negative 20 plus 36. That's 16. So this is a circle with center is at 4, negative 6, and the radius is 4. All right, so 4, negative 6, 4, negative 6. There's the center of our circle, and the radius of this circle is 4. So remember, in this chart, on this graph, we're counting by 2s. So my circle is going to be sitting over here. Now, no matter how bad I draw whatever kind of potato-looking circle I've got, I am never going to cross that line, so this has no solutions. All that work for no solutions. These authors are cruel. Okay. Uh-oh. We've got a funky-looking parabola here. Let's get this line just because it's easy. So we have y equals 3/4 x minus 1. I don't like that equal sign. All right, so that goes through negative 1, and it goes up 3 over 4. So we'll go ahead and get this line drawn. This parabola, though, it's going to take some work. I'm going to slide this screen over. I'm going to need to complete the square, and it's not going to be pretty. So first of all, I'm going to subtract the 5 and complete the square. I'm going to leave it negative y on the left for just a minute. So half of 1 is 1/2. So we have x squared plus x plus 1/2 squared minus 5 minus 1/2 squared. Negative y is equal to, this is now a perfect square, x plus 1/2 squared. And we have minus 5 minus 1/4. Now we're going to have to get a common denominator of 4 over 4. So we're going to have negative 21/4 here in a second. So I have negative y is equal to x plus 1/2 squared minus 21 over 4. This is an extension problem. multiply both sides by -1. It's just going to change the sign on everything. Because this is going to distribute. So I have y is equal to negative x plus 1/2 squared minus 21 over 4. So actually, you know what? Let me turn these into decimals. Because of the fact that we're graphing, we're going to have x plus 0.5, and then 21 over 4 is 5.25. So our vertex is at negative 0.5, comma 5, negative 5.25. And that's just hideous. So negative 1/2, that's barely right over here. And then down 5 1/4. I mean, I'm taking the best guess I've got. That's right there. And then it faces down. These guys are just jerks. Once again, no solutions because this parabola faces down. Not because it faces down, it's because of the fact it doesn't cross. So now we're to the fun problems. We got the solving algebraically. Solving algebraically. I might go a little faster on these. Maybe. We'll see. Just because of the fact that the pattern stays the same. So let's go ahead and solve for y on the line. We usually choose the line for what we solve in. So now we've got y equals negative 6x minus 16 when I subtract 6x from both sides. I'm going to take that. I'm going to substitute it in for y. I get negative 6x minus 16 plus 7 equals x squared. Since it's a quadratic, I'm going to make it equal to 0. So I'm going to move, first of all, I'm going to combine negative 16 and 7. So I have negative 6x minus 9 equals x squared. So I'll bring all of this to the other side. So I get 0 equals x squared plus 6x plus 9. You should recognize this as a perfect square already because half of 6 is 3. 3 squared is 9. So this is already a perfect square. This is x plus 3, the quantity squared. So there is only one solution, and that is if I square root both sides, I could do that, you know. I get 0 equals x plus 3, then subtract 3 from both sides, and I get only one solution of x equals negative 3. Now I need my coordinate, so I'm going to take this, and I'm going to plug it back into that, and I get y equals negative 6 times negative 3 minus 16. Y equals 18 minus 16, which is 2. So my coordinate is negative 3, 2. Number 10. Ooh, did there a different type of cut on that one? It's okay. Here I'm going to subtract 2y from both sides. I'm working with the line. So I get x equals 6 minus 2y. Decided to not mess around with it. I'm going to plug that into there. Ooh, that's not going to be too pretty. It'll be all right, though. This is just the way I chose. Doesn't make it the easiest way. Equals, this turns into 6 minus 2y minus 2 squared. This is good because it's going to reinforce our factoring skills anyways. I'm going to need a little bit more room probably. Slide that over. So I get 6, not 6 minus 2y, sorry, 6 minus 2. I can combine these two things. They are like terms, they're just numbers. 4 minus 2y squared. Now you guys have had lots of practice, so I'm going to write this one anyways, step by step. 4 minus 2y times 4 minus 2y. 4 times 4 is 16. 4 times negative 2y is negative 8y. Negative 2y times 4 is also negative 8y. And negative 2y times negative 2y is positive 4y squared. We have something quadratic. I'm going to simplify, and then I'm going to make it equal to 0. So y minus 5 equals 16 minus 16y plus 4y squared. I'm going to subtract y and add 5 to both sides. So now I get 0 equals 21 minus 17y plus 4y squared. So at this point, we need to solve for y. It's not particularly pretty, and one of the other methods might have gotten to this faster. But whatever you pick, just stick with it, and you'll still arrive at a good answer. So we have our a value. Remember, our a is whatever's attached to the y squared. So a is 4, b is negative 17, c is 21. Now this is probably factorable. Your homework doesn't necessarily give you anything too crazy, but just in case I don't want to do a lesson on factoring right this second, let's do x equals negative b, since you guys are familiar with the quadratic formula, plus or minus the square root of b squared minus 4 times a times c all over 2a. So we have 17 plus or minus square root. 17 squared is 289. Minus 4 times 21 is 84, times 4 is 324. No, 336. All over 8. Ooh, I like this. I like this because it starts off looking tough, but 289 minus 336, you guys have to realize this is going to be negative. So my x value, so where did these cross? This is a good example. Where do these cross? So we have x equals 17 plus or minus the square root. We have 336 and 289, and the difference between those is 47. We have negative 47 over 8. But this right here is imaginary. That means they don't cross. Because if they cross where x is imaginary, then they don't cross in the reals at all. So there's no intersection, so there's no solution. And that's something you can take as you go through these problems. Let's see, that was 10, right? Yeah, 10. So we're on 11. We're halfway through the homework. All right. This one looks like it won't be as bad. Let's go ahead and solve for, it doesn't really matter. Let's solve for x. I'm going to add y to both sides. And x equals 6 plus y. I'm going to take that and I'm going to plug it into here. Now here's a good, I actually like what I chose because this gives us a few things. First of all, realize that the negative sign in front of that x squared is not attached to. It's in front of, not part of the x. So that negative stays negative. I'm only replacing x with 6 plus y, so I need to bring in a parentheses when I do this substitution. Bringing in a parentheses for any substitution is a good habit to be in. Now I'm going to only square the 6 plus y. I have to do that first. So I have y squared minus 26 is equal to negative 6 plus y squared. You know, that's 6 plus y times 6 plus y. I'm not going to do all that work off to the side. You guys can do this. Okay, so that's going to distribute and combine to that. Now that negative sign is going to distribute through. So I have y squared minus 26 is equal to negative 36 minus 12y minus y squared. Let's bring all of this to the left. So I'm going to add y squared to both sides. Now that's gone. I'm going to add 12y to both sides. This doesn't have anything to add to on this side, so I'm just going to have to put it out here. I'm going to add 36 to both sides, so that's going to add right here. And it's going to equal 0. So let's bring this up over here. And we're going to have 2y squared. 2y squared plus 12y plus 10 equals 0. Everything here is divisible by 2. I like that. I'm just going to divide it all by 2. When you can see something like that, super easy to reduce it all, do so. Doesn't change the problem. Now, if this were a real life problem, it could change the intent of the problem. We have to bear that in mind. What multiplies to 5 and adds to 6? And that's going to be 5 and 1. I really don't think the quadratic formula should be used here. This factors into y plus 5 times y plus 1. And really quick, if you don't recall what's going on there, let me change to like a light blue here. If you don't recall what's going on, it's always what multiplies, as long as your coefficient in front of your squared term is 1, just look at what multiplies to your last term and adds to your middle term. That's 5 and 1. Those multiply to 5 and add to 6. So now each one gets set equal to 0. Feel free to ask this question come Monday, because you know I'll be out the next couple of days, if you have questions. So y equals -5 and y equals -1. I need my x values, so going back to the original equation, I have 6 plus -5 now, and I have 6 plus -1. So my x value is going to be 1, and my x value is going to be 5. So I get the coordinate 1, -5, and I get the coordinate 5, -1. And those are the two places that line crosses that parabola. These are lengthy. I'll be interested to see how long this video is when I'm done. So let's see here. We are on 12. How many of these are there? Ooh, oh, we're almost done. Once we hit those word problems, it starts going faster, I bet. Subtract 2x, subtract 2x. I get y equals -2x plus 1. I'm going to plug that in for y, right here. So I get -2x plus 1 minus 3 is equal to x squared minus 2x. -2x minus 2 is equal to x squared minus 2x. Let's get it all on one side, so I'm going to go ahead and add 2x, add 2x, add 2, add 2. So we get 0 is equal to x squared. Oh, and the 2x's cancel. 0 is equal to x squared plus 2. That's nice. Now going back to a long way time ago, I think 3-1, we'll have 0 equals x squared plus 2. I'm just rewriting up top. Subtract 2 from both sides. I get -2 equals x squared. I have to square root. And x equals something imaginary. So there are no solutions. No real solutions anyway. That was nice. 13. Add 1. No, I don't need to do that at all. Well, let's go ahead and do it. Let's go ahead and do it. I already started. I said you do it and you commit, right? So y equals x plus 1. I'm going to take that, plug it into y. X plus 1 equals x squared plus 1. Subtract 1, subtract x. Cancel, cancel. Those cancel too. I get 0 equals x squared minus x. This goes back to that workbook problem, number 9. I can factor this. 0 equals both of those terms, x squared and x, can give up an x. So I factor an x out, I get x minus 1. If that's throwing you off, that's from Algebra 1. If that's throwing you off, guys, you got to come to tutoring or something, okay? So now I take the first term, x equals 0, and I take the second term, x minus 1 equals 0. Add 1 to both sides, and I get x equals 1. So my two solutions are 0 and 1 for x. Now I need to get y. So y equals 0 plus 1, which is 1, and y equals 1 plus 1, which is 2. So my coordinates are 0, 1, and 1, 2. Why are 12 and 13 the easiest two problems out of here? It's kind of weird. 14. Last one. Maybe this one will be the doozy. All right, so I'm going to add 7. So I have y equals x plus 7. I'm going to take that and I'm going to plug it into that y, and I get x plus 7 equals x squared plus 2x plus 7. Oh my gosh, it's not even a doozy. They did it again. Cancel, cancel, cancel. I have 0 equals x squared plus x. Wow, happens again. Factor an x out. X times x plus 1. X equals 0. X plus 1 equals 0. X equals -1. So y equals 0 plus 7, and I have y equals -1 plus 7. Y equals 7. Y equals 6. So I get the coordinate 0, 7, and I get the coordinate -1, 6. Those were short. But they do include that Algebra 1 concept that I talked about in class for number 9. Jason is driving his car on a highway at a constant rate of 60 miles per hour when he passes his friend Alan, whose car is parked on the side of the road. Alan's been waiting for Jason to pass so that he can follow him to a nearby campground. To catch up to Jason's passing car, Alan accelerates at a constant rate. The distance d in miles that Alan's car travels is a function of time since Jason's car is passed is given by d equals 3,600 t squared. So you have to understand that they gave you a line. So here's your conic, right? Here's your curve, d equals 3,600 t squared. But since Jason is driving at a constant rate of 60, Jason's distance is always going to be 60 times t. So there's the big key there. So I'm going to take this 60t and it plugs into there. So I get 60t equals 3,600 t squared. Get it equal to 0. And I get 0 equals, I didn't cut it over, that's why the writing looks weird. 0 equals 3,600 t squared minus 60t. Same concept from number 9. I'm going to factor a t out of that. And I get 3,600 t minus 60. So here I get t equals 0. That's that first one. And I get 3,600 t minus 60 equals 0. So right here, time equals 0. That's one solution. Okay, because Jason and Alan are at the same point at the same time right when Jason passes Alan. Alan is stopped and Jason passes him. But technically speaking, for that split second, they are right next to each other. This next one is how long it's going to take for Alan to catch up with Jason. So I'm going to go ahead and add 60. So now I've got 3,600 t equals 60. Divide by 3,600. And reduce, and I get t is equal to 1/60th, sorry, those cancel. 1/60th of a second. Wow. He catches up fast. No, t is in hours. Ha, that's why. Time t is in hours. I'm silly. He doesn't catch up in a 60th of a second. He catches up in the 60th of an hour. All right. That makes me feel better. 16. The flight of a cannonball toward a hill described by the parabola y equals 2 plus 0.12x minus 0.002x squared. This hill slopes upward along a path given by y equals. I'm going to cut this one over so my writing's just a little bit better. We'll get that. We're talking about cannonballs. Where on the hill does the cannonball land? So, you've got this hill, and it's sloped like that, and this cannonball is being like shot, and there's that parabolic arc. So where is this point where it hits the ground? Right? That's the question. But we've got this, and it's substituting in for that. So 0.15x equals 2 plus 0.12x minus 0.002x squared. This is really, really hideous. So let's go ahead, though. I don't want to give up or do anything slanderous, you know. Move my thing. And we're going to multiply everything by 1,000. So we can move those decimals 3 over. So now I've got 150x equals 2,000 plus 120x minus 2x squared. Matter of fact, I'm going to keep going, and I'm going to say everything here is divisible by 2. Just trying to make my life a little easier. And sometimes a little more work makes our life a little easier. I'll bring everything over to the left side, so I'm going to bring all this over. They're all going to change sides. I'm going to subtract 60x. So I'm going to end up with x squared plus 15x plus 1,000 equals 0. Now I could ask myself what multiplies to 1,000 and adds to 15 using that same algorithm. Right? We have 200 times 5. That's not going to work. But what if I said 40 and 25? Problem is, everything here is positive. So I feel like I may have done something wrong. For time purposes, when something looks like this, they're practically begging you to use a graphing utility. So let's do it. 2 plus 0.12. And if you guys want to come and tell me where my error, if any, is, by all means, tell me Monday. Or Thursday, Friday if you see me walking around campus. All right, so I'm going to go to Desmos. 2 plus, see if I can remember that. Two plus 0.12x minus 0.002x squared. That's going to be equal to y. And then we're going to have y equals 0.15x. So they definitely cross. Let me make sure I got all those right. 0.15x, 0.12, 0.002x squared. Fantastic. And they're going to cross. We can see that they're going to cross. I'm just going to have to find where they cross. And it's here. 25 seconds in, they cross at 3.75. So, at time equals 25 seconds. Oh, where on the hill does the cannonball land? So, that's what we're looking at. So, it landed at 3.75. So, this point right here was 25, 3.75. This is the flight of a cannonball along a path. So, the output is saying where does it land? It lands, doesn't say what the units are here. Overall, I'm not too happy with this question. So, but the ball lands at 25, 3.75. I'm not sure what they mean by where on the hill does it land. Okay, Amy throws a quarter. So right now, guys, it's 4:56. I'm going to need to pause. And unfortunately, that means that this video will not come to you until after 7, because I've got to get back to it. Sorry about the delay. Had to do parent-teacher conferences and do a little bit of closing up of the campus. 8:15. Sorry. So Amy throws a quarter. It's still the same thing. The quarter's thrown from the top of a building. So just visually, let's go ahead and cut this so we can see visually what's going on. So this building's about 64 feet tall. Okay, and quarters being thrown. At the same time, a balloon is being released. We're trying to see when, after how many seconds will the balloon and quarter pass each other, and check for reasonableness. So we check this, we're going to plug it into here. 6x plus 8 is equal to 64 minus 2x squared. Let's get this equal to 0. I'm going to bring this over. X squared can't combine with anything else. 64 is going to combine with the 8. So this equals 0. I have 2x squared plus 6x minus 56. I can divide all that by 2 to make my life easier since those are all even numbers. X squared plus 3x minus 28 equals 0. So multiplies to a negative 28 and adds to a positive 3. That is x plus 7 times x minus 4. If you guys need tutoring on factoring trinomials, make sure you guys come in, okay? So this would be at -7 seconds, or at 4 seconds, the balloon will pass the quarter. Well, since we can't have -7 seconds, the answer is after 4 seconds, the balloon and quarter will pass. The range of an ambulance is a circular region. X squared plus y squared equals 400. A straight road within the surface area is represented by y equals 3x plus 20. Find the length of the road in miles that lies within the range of the ambulance service. Ooh, okay, this one's a little beefy. So, I don't need that picture. So, just really quick, what they're saying here, as a quick sketch for our thought, right? So they're saying an ambulance has a circular region and that there's a road that cuts through it, right? So they're saying that these two dots would represent where the road cuts through, and they want to know that distance. So we need to get these coordinates, and we need to find the distance between them using the distance formula. So y is 3x plus 20. I'm going to plug that in here. Whoop. Okay, so now we have x squared plus 3x plus 20 squared means 3x plus 20 times 3x plus 20. You guys can distribute that out, but that's going to be 9x squared plus 120x plus 400 equals 400. Yeah, I'm good with that. Get that equal to 0. And I'm going to combine these terms here, so I get 10x squared plus 120x equals 0, because those just canceled. I can factor a 10x out of this. So factor 10x out, I get x plus 12. So x equals, so set each one, 10x equals 0, x plus 12 equals 0. So x equals 0 and x equals -12. Those are my two x coordinates. Let's get our y's. Y equals 3x plus 20. So y equals 3 times 0 plus 20. Y equals 3 times -12 plus 20. So y equals 20. And y equals, this is -36 plus 20 is -16. So our two coordinates, I'm going to delete my sketch. My two coordinates are 0, 20. And -12, -16. What's the distance between these? So we're going to use our distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. 12 minus 0 is 0, or sorry, it's 12. And 12 squared is 144. -16 minus 20 is -36. So we have 36 squared. And 36 squared is 1,296. So now we're going to add 144 to that. We get the square root of 1,440. Now that's 144. So that's round to your nearest 10. That's not a square root number, so that's going to be 37.95 miles. All right, 18 was kind of big. Kind of big. 19. Oh, matching. We got some easy stuff here. I'm not even going to copy it over. So, match the equation with their solutions. So if you notice, guys, They are playing you a little bit. All right, maybe. But we can narrow this down. So right here, let's think about D, or not D, let's think about this last bottom one. So actually I will cut this over. It's a little harder than I thought it was. At least a little bit more thought than I thought. Ba-dum-bum. Let's take a look at this bottom one though. This is a parabola, just thinking about it. I'm talking about this bottom one here. Okay, this is a parabola shifted 2 to the right. So it's going to hit that spot. And this is just a horizontal line. This is the x-axis. That only has one solution. So this one definitely has to be C. All right, now I'm going to think about this one here. That's a circle centered on the origin, radius 5. And y equals, if I divide both sides by 4, this is y equals 3/4 x. So it's an up 3 over 4 line going kind of through the origin. Which one looks like, so this is going to go through 2 spots, and it's going to be A. It's the only thing that matches that graph. So this is kind of pulling in like a little few quick, easy techniques from previous sections. So this one here, that's a parabola shifted 2 to the right, again. And then a line that goes through -8 and has a slope of down 5 over 1. They'll never cross. So this one's D, no solution, which leaves this one to be B. That was a little more than I thought. That was the thought process that goes into it. Now, if you need to solve all those, you're just really working too much there. Students solve the system graphically and determine the only solution to be 1, 3. So we're looking at this graph to the right. Was this a reasonable answer, and how do you know? No, this is not a reasonable answer. How do we know? Because of the fact that, yes, it crosses there, but they didn't take into account the fact that our line keeps going forever and our parabola keeps going forever. So they are going to cross again at some point. So to answer 20, you'll have to listen. I'm not going to write all that down. You guys got this. I'm going to render this video, and you guys can hopefully get it done tonight. So if you listen to the whole video, I am not going to have my substitute teacher, which will be my wife, collect these tomorrow. I will probably not collect these until Monday. All right, have a good one.